Welcome to Stelligent's DevOps on AWS Radio, with your hosts, Paul Duvall and Brian Jakovich.
Welcome to our 21st episode of DevOps on AWS Radio. I'm Paul Duvall, CTO at Emphasis Stelligent. With DevOps on AWS Radio, we get into detailed discussions about applying DevOps practices on AWS. If you are interested in being a part of our team, you can go to stelligent.com/careers. We're hiring engineers and managers. And if you're not only interested in talking about DevOps, but actually applying these DevOps engineering practices and organizational change and so forth with enterprise customers, definitely reach out to us. In this episode, I have a discussion with Casey Lee, who's our chief architect and also VP of engineering and delivery at Stelligent. And Casey is also an AWS container hero. So we get into a discussion on everything about containers on AWS. So let's get into some DevOps on AWS news. And most of what I'm going over, we covered in a webinar last week. And that webinar also has an accompanying blog post. And so if you go to Stelligent's blog and look for AWS reInvent 2018 DevOps Recap, this covers most of what I'm going over here. But we had the highlights from a DevOps perspective of reInvent. And of course, reInvent had 80 plus product announcements. And so we went over things like AWS Code Deploy now supporting blue-green deployments for ECS and Fargate, how Code Pipeline has announced support for ECR as a source provider. There's also faster pipelines, more actions you can put within stages, and also the support for VPC endpoints. We talked about AWS Lambda now supporting Ruby, also layers and custom runtimes. There are two new services for security and governance. One's called AWS Control Tower. The other is AWS Security Hub. And then we talked about a number of VPC and related announcements, such as sharing VPC subnets, the announcement of the AWS Transit Gateway, and some other announcements in the VPC space as well. And so, again, you can check out the blog post, but we also have a 58-minute webinar that Casey and I went through, in which we went into detail all these announcements and how we think this is impacting the DevOps on AWS community. Okay, so now I'm going to get into my discussion with Casey Lee. We talk about everything and anything when it comes to containers on AWS. And so we're talking about ECS, EKS, and a lot of the open source tools in the Kubernetes world, and then how that relates to EKS, or really just doing Kubernetes on AWS. We get into Fargate and then go over some of the similarities and differences between some of the service offerings in the container space. And we just get into a lot of detail on how to do and really how to best implement containers on AWS. So definitely check this one out. It's good detailed technical discussion on containers with Casey Lee from Stelligent. Hey Casey, thanks a lot for joining the podcast. I know we talk probably every day, but we're not talking about containers every day. So I appreciate you joining the podcast. And maybe we can start things off and talk about what you're hearing from customers as it relates to containers.
Yeah, sure, Paul. Thanks. So we're still seeing a lot of new customers coming to us wanting to talk about how to run their container workloads on AWS. A lot of organizations, large enterprises that we tend to work with, they are looking for opportunities to re-platform existing workloads that might be on-prem or that might also be on AWS already on traditional EC2 instances. They want to re-platform those to run as containers, and their motivation usually just comes from either cost. They're looking for getting more density and being able to change the model in which they're deploying the lines closer to the size of resources that the application needs, or they're looking for better developer parity and agility. They want to be able to have deployment units that are easy for developers to run locally, so they can build these images locally, evaluate them locally, and then have greater confidence on how those are going to look in a deployed model. So that's generally where their motivation comes from. And so again, we're seeing this is a lot of brownfield development. These are customers that have existing workloads, and they're just looking for opportunities to re-platform to get some of those benefits.
And what approach are people taking to running those container workloads on AWS?
Yeah, there's definitely a lot of options that AWS offers. So the first question that people need to consider is, do they want to run using something like ECS or are they interested in using something like Kubernetes? So ECS is the managed service that AWS offers for running container workloads. It's very mature. It's been out for quite a while. It offers a lot of benefits in that it has tight integration with the rest of the AWS environment, nice integration with IAM. You can have containers running inside of VPC, integration with CloudWatch logs and CloudWatch metrics, auto-scaling capabilities, and you can do all your configuration through things like CloudFormation. So ECS offers that nice native AWS experience. But then that brings downside with it. When you run an ECS, you are committed to AWS. It's an AWS specific type of a model. But if you go with ECS, you then have another choice you have to make, and that is because ECS is just the scheduling and the orchestration. It's the layer that you tell ECS what type of services you want to run, what containers you want to run, and ECS does the job of scheduling those services. But the scheduling and the actual running of the containers does not happen on ECS. It has to run on actual infrastructure, and this is where the second choice comes in. You have to choose between, do I want to run my ECS workloads on EC2 instances, or do I want to use Fargate? So Fargate was an announcement that AWS made last fall, right around this time, around the reInvent announcement cycle. And what Fargate offers is a solution where AWS manages the infrastructure that you actually run your workloads on. So ECS is the scheduling. That's where you tell, hey, I want to run these containers. And then Fargate is the actual engine that those containers run on. So you have to make a choice. Do I want to run on Fargate versus EC2? So that's kind of the ECS path for folks running containers. What about the Kubernetes path? So you've got a bunch of options on this path as well. So first of all, why would somebody choose Kubernetes over ECS? Well, the primary motivation is it's cloud agnostic. Kubernetes is its own open source project. It's not tied to one specific cloud provider. But the downside being with Kubernetes, you have less native integration with the cloud provider. So there's three different options that we see customers looking at when it comes to choosing the Kubernetes path. First is EKS. EKS is AWS Managed Kubernetes Service, and it's very similar to ECS in that it's that scheduling layer. It represents the cluster of master nodes for Kubernetes. It's the control plane. EKS is a bit more immature as compared to the other Kubernetes options that I'm going to talk about, and it's a bit less AWS specific and less integrated than over something like ECS. And it's really worth noting, AWS did a nice job here in that they intentionally wanted EKS to offer customers an upstream experience. And what I mean by that is it's not like they're hiding Kubernetes under all this other AWS SDKs. When you provision Kubernetes with EKS, you get a Kubernetes cluster that you then use open source tools like Kube-Control to manage the Kubernetes cluster. So EKS is one option. The other options for Kubernetes is using something like kops or just roll your own CloudFormation templates. This requires a heavy amount of engineering. We see a few customers do this, but it gives them the most control, but it also requires a really high level of engineering talent. And the last option for Kubernetes on AWS that we're seeing quite a bit of customers looking at is looking at purchasing support through a vendor like OpenShift and PCF, Pivotal Cloud Foundry, are the primary models that we see here. Benefits being you got vendor support, very mature, but the downside is these things are expensive. So yeah, so that's kind of the options. You have to choose the ECS path or Kubernetes path, and then down those different paths, there's additional other choices that tend to show up.
So you had touched on this a little bit, but you had mentioned that ECS and EKS and Fargate, they're all managed services, right? So how are they related and how are they different?
Sure. So ECS and EKS are that scheduling layer. They're the control plane. So no actual work is running in ECS or EKS. So they're just there for the purpose of registering the intended state of your containers. You tell ECS or EKS, hey, I want 10 containers and I want them to autoscale in this way. And then ECS or EKS do the job of managing the deployment and keeping those containers running. But they do that on a different layer, which is where Fargate comes in. So Fargate is also a managed service, but it's not managed in the sense that it does the scheduling. Fargate is just an engine upon which you can run your containers. So ECS schedules the running of your container on Fargate. EKS schedules the running of your container. Doesn't currently have support for Fargate, so you have to run your own EC2 instances, but EKS schedules the running of your containers on your own EC2 instances. Now, what's the difference between ECS and EKS then? Well, both of those are managed services. Both of those are the control plane. The difference being ECS is a AWS proprietary, if you will, scheduling system, and EKS is Kubernetes.
Okay, I want to go back to something you mentioned before, and that is that a lot of brownfield projects are using containers. Maybe you can go into that. What's the reason for that, and what are you seeing in terms of decisions around containers and serverless?
Yeah, great question. So serverless is a fantastic architectural pattern for running workloads with extreme high scalability and cost optimization. The challenge becomes if you have an existing application and you want to get some immediate bang for the buck, you want to get some quick wins on things like the way in which you're scaling the application or the agility that you have in deploying the application, there's often not an opportunity to re-architect the app. If I've got a Java application and I want to change the way it's deployed, I might not have an opportunity to re-architect that so that it leverages a good serverless cloud native experience. And that's what we're seeing. So organizations have these Java apps and they're like, hey, we can deploy these as containers pretty easily. We could see how we can take this app that's currently running on an EC2 instance inside Tomcat or something and get it running inside of a container and then get all the benefits of ECS or EKS. But it's a lot harder ask to take that brownfield app and split it up and deploy it properly with serverless. At least that's what we're seeing.
So you mentioned some limitations with EKS versus running your own Kubernetes cluster. What are some of the examples you can share?
Yeah, sure. So EKS is a managed Kubernetes cluster that AWS offers. And so they own all the details of how those master nodes are configured. You have no visibility into them. You can't log into them. You can't change their configuration. Basically, you can say, hey, give me a Kubernetes cluster, and that's really all you can say. So, for example, when EKS first came out, HPA was not supported. HPA is horizontal pod autoscaling. So what that is it's like the equivalent of ECS service autoscaling. It's where you could say, hey, I've got this service that I want to run in Kubernetes. I want 5 pods running, but I want to be able to scale out and scale back in based on CPU for those pods. In Kubernetes speak, that's called HPA, horizontal pod autoscaling. That did not work on day one with EKS. And the reason why was because there's this thing inside Kubernetes called metrics server. Metrics server is what gives you visibility into these different metrics that you can do autoscaling on. And metrics server requires this other construct in Kubernetes called API aggregation, basically where you can run something and it exposes an API that gets molded into the native Kubernetes API. So metric server needs API aggregation, HPA needs metric server. Okay, now the problem was API aggregation, it only works when you're doing certificates for authentication. Well, EKS didn't use certificates for authentication. They use webhooks for authentication. The reason they did that is because EKS supports integration with IAM. Okay, so replay that. EKS uses IAM, which needs webhooks instead of certificates. By using webhooks instead of certificates, API aggregation doesn't work, which causes metric servers not to work, which causes HPA not to work. So you've got this very important piece of Kubernetes, the ability to autoscale, not available to you because of the fact that EKS uses IAM integration. Now, what was awesome about this, though, this has been fixed. The way that AWS addressed this is really awesome, actually. Rather than them coming up with some mechanism deep buried inside of EKS that works around the issue, they made an upstream change to the open source Kubernetes project that adds support for webhook authentication to API aggregation. By making that change, it fixed all these problems downstream into EKS, but it also helped add functionality to everybody else that's using Kubernetes outside AWS. So really class act way that AWS addressed this, and really goes back to the fact that they really are trying to offer as much as possible native Kubernetes experience.
So let's talk about cost a little bit. How does the cost compare between all these options that you talked about?
Sure. So ECS is the easy one. ECS is free. You don't pay there's no cost for ECS scheduling your workloads, but you do pay for the actual workload itself. So ECS runs your containers either on Fargate or EC2, and the pricing model is very different there. If you choose EC2 as your launch type from ECS, you're just paying typical EC2 pricing. So let's look at an example. Let's say we've got 25 services running, and we're using M5 large instance type for our autoscaling cluster. So to get these 25 services running, let's say we need 3 instances, M5 large instances. So we're looking at about $300 a month, and that could go down if you're using reserved instances, but so about $300 a month. Compare that to Fargate. If I'm using ECS and I choose the Fargate launch type, now I'm not paying based on instances. I'm paying more like a Lambda model where I'm paying based on memory and CPU utilization over a duration. So Fargate pricing is you pay per second based on how much CPU and memory you allocate. There's a minimum of 1 minute. So even though you're paying per second, you're paying up to that minute. So if we take that same sample, 25 services, and let's assume we're only allocating a quarter of a vCPU and half a gig of memory, I'm looking at about $350 a month. So you're paying a premium to use Fargate over EC2 launch type. In this example, 350 versus 300, and that 300 again could be even less if you're doing RIs. But so you're paying a premium, but what you're getting for that is I'm now no longer having to manage EC2 instances. I don't need to manage patching or AMIs or the responsibilities that come with those EC2 instances. I'm able to leverage the managed service for that. EKS has a different pricing. So although ECS is free, EKS as a control plane is not free. You're paying, as of this time, it's 20 cents an hour, which works out to be just under $150 a month just for the control plane with EKS. You then need to add the EC2 instances for the workload. So you're paying a premium for EKS over ECS and a small premium for Fargate over EC2 launch type.
So in the case of Fargate, you're essentially able to reduce your labor costs because you're not having to manage that. What about things like auto-scaling? Is that also a part of it?
Yeah, that's a really good point. So the total cost of ownership, you have to factor in labor costs because now I'm spending less time managing all of the instances. Auto-scaling with the EC2 launch type, the auto-scaling gets a lot more complicated because not only do I have to manage the auto scaling of the service, but now I also have to manage the scaling of the EC2 instances, the container instances that ECS is scheduling my containers onto. So I've got to scale out and scale in my EC2 auto scaling group based on things like maybe memory or CPU utilization. And then I've also got to scale out and scale in the service. So by using Fargate, I'd no longer have to think about those 2 auto scaling dimensions of the EC2 instances and the ECS service. Now I just focus on the ECS service, no more thought on EC2. So yeah, it definitely simplifies auto-scaling.
So what about integration with other AWS services like IAM and auto-scaling? How does that compare between ECS and EKS?
Sure. So let's talk about IAM first. ECS has very tight integration. ECS, each task can assume its own IAM role. So when you define the task, you can have many tasks running in a single cluster with different IAM roles so that those tasks can access other AWS resources with that IAM role. EKS, not so much. Out of the box, everything runs as whatever instance profile and IAM roles associated with the EC2 instance that the pods are running on. There is an open source project called Kube2IAM, and it's pretty clever. What it does is it intercepts traffic from the pods that are trying to talk to the EC2 metadata API, intercepts that traffic and reroutes it over to STS, gets temporary credentials, and then returns the temporary credentials to the the pod. And so you are able to get the same kind of experience where pods can use different roles, but it requires this open source tool, Kube2IAM. And the IAM integration is also a bit different when it comes to administration. So ECS, all administration is authenticated and authorized through IAM. But with EKS, it's a little bit different. They do have integration with IAM, so you can use the native Kubernetes tools like kubectl to be able to do configuration, but it requires this thing called AWS IAM Authenticator. It's a plugin for kubectl that makes API calls back to AWS to get temporary credentials to communicate with EKS, with Kubernetes. It's also worth noting ECS, everything is configured can be configured through CloudFormation. With EKS, I can define the cluster with CloudFormation, but then everything inside the cluster, all the pods, the services, ingress, anything that I want to define internally, you're not using CloudFormation, you're not using anything AWS, you're using native Kubernetes, things like spec files and tools like kubectl. The other one you mentioned was autoscaling. So ECS has very tight integration with autoscaling, both for the container instances and for the services. Talked about that a little bit before. EKS, no integration with autoscaling. So these are things that instead you're using native Kubernetes constructs. So for example, to scale the EKS cluster, the EC2 instances that support the cluster, you're not using AWS autoscaling. You still create an autoscaling group, but there's no scale policies for that autoscaler group. Instead, open source tool, you're catching the pattern here, open source tool called Cluster Autoscaler. You run Cluster Autoscaler. It's just a deployment that you run inside your cluster, runs on the master nodes. And what it does is it monitors the internal health of the cluster. It's looking for pods that fail, maybe due to insufficient resources, or nodes that are underutilized for scaling. And so this cluster autoscaler pod notices these things, and then it uses the IAM role associated with it to reach back out to autoscaling service and manually change the desired count on the autoscaling group to scale out or scale in. So rather than CloudWatch driving the scale out, scale in, you've got this pod running inside the cluster, reaching out and doing the scale out, scale in of the cluster. So the other autoscaling that EKS has to deal with is the autoscaling of the pods themselves, which is using HPA, horizontal pod autoscaling. That's 100% Kubernetes. There's no AWS autoscaling involved there, no CloudWatch metrics. It just uses the internal metric server and uses that to trigger when pods should scale out, scale in.
Hey, Casey, I want to go back to, you were talking about how ECS, you're only charged based on the EC2 instances that you're using, but with EKS, it's 20 cents. Was it 20 cents an hour? What's the reason for that, do you think? Is there some other set of AWS services that are being used in which they're charging for that?
Yep. I suspect that when you provision a new EKS cluster, there are EC2 instances being stood up on your behalf to be the master nodes for that Kubernetes cluster. So the point being, it is not a shared resource. It is allocated specific for that cluster.
Got it. I also I'm curious about the integration with, say, CodePipeline, the continuous delivery orchestration service. So it has native support for ECS as one of the deployed providers. Is it providing the same kind of thing with EKS?
Nope. A couple reasons there. So you can manage your EKS cluster not through a native integration with CodePipeline, but through CloudFormation. So there's a CodePipeline has native integration with CloudFormation. I could have a CloudFormation template that defines my Kubernetes cluster, and that could be managed by CodePipeline. But the actual deployments themselves into Kubernetes is a completely AWS agnostic approach, meaning you have to use things like kubectl, the command line tool, to deploy resources. So the approach there would be use something like a code build step in CodePipeline that could run kubectl to make deployments into the Kubernetes cluster.
How's the approach to networking different between the various options you've gone over?
Sure. So ECS, either with the EC2 launch type or with Fargate, has a 100% native experience with VPCs. So when you create your tasks in ECS, you can associate ENIs and EIPs with those tasks. And then from there, there's also native integration with load balancers, ALBs, application load balancers, or NLBs, network load balancers, so that as ECS manages the provisioning of new containers, those containers get automatically added or removed from ALBs and NLBs. And then one other kind of network type component that ECS offers is relatively recently support for integration with Route 53 service discovery. Route 53 service discovery is, at the end of the day, just another hosted zone in your Route 53 environment. And what's cool about this is then ECS, when it provisions new tasks, it automatically updates the hosted zone in Route 53 with A records and SRV records for that task. Now, networking on the EKS side is a bit different. You have a couple options here. The default option is to use an open source plugin that AWS has called the CNI plugin. CNI plugin will automatically attach ENIs onto your EC2 instances and then EIPs per pod. So what ends up happening is each pod can get an EIP in a VPC as those pods come into and out of service. So you get the equivalent of like that native VPC experience for your EKS workloads. There's some limits there, though. EC2 has limits based on your instance type on how many ENIs and how many EIPs can be associated with it. So if you have a high density, a large number of pods you're planning on running on an EC2 instance, that's going to be a problem. And so there is another option that EKS offers, which is Calico. Calico is a open source solution for doing a network overlay. So you're using this network overlay deployed into your cluster instead of ENIs and EIPs. And not only does it offer the network overlay for the interpod communication, but also you can define network policy. So this is the equivalent of like a security group. So instead of defining security groups, because Calico is not using ENIs, Calico you would define these policies to specify which pods can communicate with each other. EKS also does have some integration with load balancers. You can create a Kubernetes service with type load balancer, and then it would provision a classic load balancer for you that would handle the traffic. But typically, that's only used for defining the ingress service being like an Nginx deployment inside Kubernetes that then does the proxying to the internal services. So it's not a common pattern to see a bunch of services inside a Kubernetes cluster, each with their own load balancer. Typically, those are coming through a shared ingress. And then service discovery is a bit different with EKS. No integration with Route 53's service discovery solution. But a couple options you see here is the cheapest, easiest one is to just use Kubernetes services with cluster IPs that route through kube proxy. You also have kubedns at your disposal. So each service and each pod gets its own DNS registration in the internal DNS provider in the Kubernetes cluster. And then for a mesh type of a solution, a lot of folks are running Istio and Envoy for proxying for doing client-side load balancing and authentication authorization through the Istio sidecar.
So between ECS, EKS, and Fargate, how does the approach to automation change?
So ECS, you get a completely native AWS experience. CloudFormation is the way that we recommend configuring ECS. And you've got a lot of different options on how to handle deployments. You could do like a rolling deployment where you're swapping out individual tasks as you do updates. ECS also supports a full-on replacement update, kill the old, bring in the new, and then a blue-green type deployment option. ECS supports health checks from the load balancer. So if an ALB detects that an instance, that a task is unhealthy, ECS can kill and replace it. You'll see that ECS is a bit slower on startup and teardown than EKS. Fargate, even slower than that. It takes a little more warm time for Fargate to get going. EKS, you can use CloudFormation for the cluster itself, but everything else has to be done through native Kubernetes tooling like kubectl. Often we see folks using Helm, another open source product, for doing packaging and versioning of Kubernetes resources rather than just using kubectl directly. But you've got a similar set of deployment options like rolling, replacement, and blue-green available internal to Kubernetes, though, nothing EKS or AWS specific.
For the latest DevOps best practices on AWS, follow our blog at www.stelligent.com/blog.